Hello everyone. In this question, we are asked to evaluate the integral of t raised to the power 4 plus 1 entirely divided by t raised to the power 6 plus 1. Okay, so this is a rational function and the limits of the definite integral are from t goes from 1 to t goes to 2. Okay, so let us start this integral. Okay, so we are, let me change the color first. Okay, so the integral goes from 1 to 2 and we are given a fraction, a rational function. In the numerator we have t to the power 4 plus 1. In the denominator we have t to the power 6 plus 1 dt. Okay, so let us first start to factorize the denominator of this integral. Okay, so since this is 6, this can be written as s square whole cube, and 1 also can be written that way, so we can write it as a cube plus b cube or a square plus b square. Okay, I think it is better to factorize it as a cube plus b cube. So we can write this term as t square whole cube plus 1 whole cube. Okay, so this will become a plus b, where a is t square. Okay, t square whole cube plus 1 cube, and I'm keeping the denominator for the time. I'm keeping the numerator for the time being as it is. Okay, so we get, if we use the formula a cube plus b cube, this becomes t square plus 1 times, this will become a square, so t to the power 4 minus ab will become minus t square plus b square, which is 1 square, which is 1. Okay, so you see we have t to the power 4 minus t square plus 1. Okay, so if we see in the numerator we already have these two terms here, t to the power 4 and plus 1. So if we use a minus t square plus t square, we can try something. Okay, so let us do that. So here I am using a minus t square here, introducing, so I have to add another t square later on. Okay, so after this, if we start to separate this into two parts, okay, we have in the first integral, this term and this term will cancel each other, so first integral will become dt upon just t square plus 1, and the second integral, this will become t square upon, I think it is, for the second one, let us again revert back to the original format. Okay, the original format, that is the original denominator was t to the power 6 plus 1, right? So let us go back to that for the time being, dt. So you see the first integral is very easy. This is just 10 inverse t. Okay, so this becomes 10 inverse t with limits from 2 to 1. And for the second integral here, if we write it as a square plus b square, that is, if I try to write it as t cube square plus 1 square. Okay, so then if I keep it for the time being as it is, in the next step, if I take this denominator, or not denominator, I think if I take t cube equal to u, okay, if I do the substitution u equal to t cube, then du will be 3t square dt. So du upon 3 will be your t square dt, right? So in this case, the limits of integral will change from t equal to 1, u will be 1, and for t equal to 2, this will become 8, right? So for the second integral, we can write it as 10 inverse 2 minus 10 inverse 1. This is from the first integral, and for the second integral, we can do the substitution as t square dt is just du upon 3. Okay, so we can write it as 1 by 3 times du upon, this is u, right? So u square plus 1, and limit will change from 1 to 8, right? So this now just becomes 10 inverse of 2 minus pi by 4 plus 1/3 integration of du upon u square plus 1, right? So this is again the integral of 10 inverse u, right? So we have 10 inverse 2 minus pi by 4 plus 1/3 times 10 inverse u, where the limits are from 1 to 8. Okay, so this now becomes 10 inverse 2 minus pi by 4 plus 1 by 3 times 10 inverse 8 minus 1 by 3 times 10 inverse 1, right? So now it becomes 10 inverse 2 plus 1 by 3 10 inverse 8, and we have minus pi by 4, and this becomes 1/3 pi by 4, right? So this becomes pi by 12, right? 1 by 3 times pi by 4, so this becomes pi by 12. So the final answer now becomes 10 inverse of 2 plus 1 by 3 times 10 inverse 8, and this minus pi by 4 can be written as minus 3 pi by 12, right? So this becomes minus 4 pi by 12, so this just becomes minus pi by 3. Okay, so I think this is the required answer. Okay, so this is, I believe, is the required answer. This was I think a question in JEE or some exam, so there were 4 options given. I think this is the correct answer. Okay, so this is it. This was not that difficult. You just need to do this factorization first, split them into two integrals. This is partial fraction, and after that you just need to do this manipulation for the other integral, right? So which is a simple substitution, and the rest is just computation, and this is not that lengthy. Okay, so this was again another relatively not so difficult question from integration. Okay, so this is the required answer. Thank you for watching.